everyone, and welcome to the 28th episode of MSME Masterclass.
Afternoon. Yeah.
Today, I would like to introduce Vijay Wani, a visionary leader and the CEO of GoGreen Ventures, the forefront entity in India's dynamic solar power sector. Since its inception in 2003, GoGreen Ventures has been a beacon of sustainable innovation, dedicated to pioneering cutting-edge solutions in solar energy. Under Mr. Wani's astute guidance, the company has established itself as a trailblazer specializing in the comprehensive spectrum of solar net metering systems. His leadership philosophy is grounded in a profound understanding of global market dynamics, enriched by years of experience in navigating the intricacies of the professional landscape. Welcome to our MSME Masterclass, sir. We are happy to have you in today's episode.
Thank you. Good afternoon.
Since the topic for today is installation techniques and best practices in solar applications, we will quickly jump on to our first question, which is, what are some key considerations when selecting the steel for solar installation, sir?
Okay, selecting steel basically entirely depends on type of installations that you're trying to do. It's a ground installation, JSW roll formed steel sheets which are hot dip galvanized, pre-galvanized, are formed into purlins, and then ground level installations are done that way. Even for quite a few rooftop installations, such steels are also used. But for some superstructure sort of rooftop installations, we normally use I-beam sections. They are like quite strong and have a durable life for 30 long years minimum. The steel again requires to be hot dip galvanized according to government standards. And 80 microns is the prescribed galvanizing that is basically required. So those are the steels that normally we utilize.
Okay. Could you also walk us through the typical process of incorporating steel for solar applications?
Again, everything depends on the type of project that we are trying to do. As I earlier told, if it's a megawatt type of ground level installation, hot dip galvanized 80 microns JSW roll formed studs are the best in the line. And again, the same thing happens for rooftop. Again, on rooftop, it could be a tin shade mounted solar, or it could be a concrete slab mounted solar structure, or it could be a concrete slab mounted superstructure. So again, the thickness of the purlin will vary from site to site. It could be I-beam, it could be 2 mm thick roll formed steel. Either of them. Those will be the basic criteria to select while doing a particular site.
Got it. And share with our attendees what are some of the common challenges that we encounter during the installation of steel structures for solar projects?
For rooftops, predominantly the situation is people do not let you drill or puncture the flat terrace surface, because today everything is okay, but after 2-3 monsoons it starts leaking and then the blame game starts. So I would recommend that none in the solar industry doing a rooftop installation should basically drill the flat slab of your terrace, of the client's terrace at all. Instead, use some stub columns or some other different techniques that are available in the market, or stick the base plate onto the existing slab and then redo it with a concrete block, so that there's no piercing the flat terrace. That would lead to the longevity of the project and a good relation between the customer and the vendor altogether.
Okay, understood. Sir, are there any specific design principles or engineering standards that should be followed when planning a solar installation with steel structures?
Yeah, for steel structures, the situation is the solar panel is probably like 2.25 square meter in dimension. So the wind blockages that particular panel is going to have on the incoming winds, the structure should be designed in a way to withhold those kinetic forces from the nature. So again, on a ground, it is okay, we can do anything, but for a rooftop, a StatPro analysis or certain other engineering analysis tools are available, and we should basically design the structure taking those tools to help us out in designing the structure altogether. Else, it will be a big fiasco. Someday you'll find everything is just flown off, because a 10 kilowatt solar system would definitely require nothing more than 200 square meters of wind blockage, because that will be their faceplate value of it, and that much part will be obstructing the wind, and we have to have the structure holding it firm to the ground in that way.
Understood. Can we discuss the importance of site preparation and foundation design in ensuring that the stability and longevity of steel structures is maintained for solar projects?
So while doing a foundation, it is basically necessary that our steel structure should be hot dip galvanized. Now, what is going to exactly happen is, if we are trying to do a painted MS painted structure, the part that is below the concrete is well protected, but the part that just comes out and goes to the skywards, that particular 1 inch or 2 inch above that is the most prone segment for rusting and corrosion, which will definitely lead to disaster for the entire solar system. So at that particular point, it should be 100% hot dip galvanized, and for extra protection, some silver paint or some particular oil paint will also be a more better precautionary measure that has to be taken. And in the concrete, again, your purlin should have fins coming out of it, so that the concrete will be truly glued to your verticals.
So, because you were talking about galvanization, can you also, and this is a term that we've been hearing a lot of late in all our masterclasses, can you also elaborate on what are the importance or what is the advantage of having a galvanized product?
The advantage of having a galvanized product is that you need not paint it at all for life. So typical duration could be 15 to 20 years depending on the galvanizing process, thickness of the microns that has been used for galvanizing. This will basically enable or ensure that the steel which is there on your terrace or in the fields is basically exposed to a lot of heat, to a lot of cold, to a lot of wind pressures, to a lot of stress and strain. So the moment it is galvanized, everything of this is already counted for or acted upon in what you would call before getting installed. So we will be preempting all the problems that we are going to face henceforth. And as the solar panels nowadays come with a 30-year warranty. So the earlier standards were like 80 microns. I believe we should redo that standard to at least 120 microns, because the structure also needs to stay for that long.
Correct.
So no painting, repaintings are required at all. And if some owner forgets to repaint, it will lead to a fiasco.
Absolutely.
Yeah.
Can we also discuss some of the innovations and advanced techniques for optimizing the installation process?
Perfectly. So the optimization of such installation processes is like basically the industry norm is we install everything in a hexagonal formation where one panel is behind the other. There's a small gap left in between because the shadow doesn't touch the earlier panel's shadow, shouldn't touch the backside panel, else generation will affect. So instead of that, what we have devised or what we have designed is a single line installation where the panels will not be one below the other, but the panels will go that way and exponentially rise, and there'll be no panel which will be in shadow at all because they are just in line with the other. Here, the structure cost increases drastically and dynamically. That is the most important financial problem that we could say. But now that the government has come up with a great situation where they give 18,000 rupees per installed kilowatt as a subsidy to residential sector only. So the situation becomes a viable solution. Suppose a particular building basically required 100 kilowatt but they have a floor plate dimension which is a bit lower. And if we try to do hexoplate formation, we'll hardly install 30 or 40 kilowatt. But in a single line installation, the way I talked about, we'll be able to cover 100 full 100 kilowatt, and that adds up to the benefit of the customer because his bill goes down to zero. He gets a good subsidy, and things match up.
Absolutely. So, because you were talking about government subsidies and how
Mhm.
that has been helping with the
Public
entire
at large.
process.
Yeah,
Yeah.
yeah.
Could you also share with us if there are any other government initiatives or subsidies or incentives that could possibly help the MSME sector at large?
MSME sector basically is already paying a good amount of income tax. So for MSME segment, there's something called as accelerated depreciation. So the government has already rolled out a policy wherein 40% basic accelerated depreciation per year until your value depreciates to zero is applicable for MSME segment. And just like it's 30% subsidy for residential, eventually it adds up to 30% in your income tax rebates altogether for MSME. So this is the right time, and the government is playing their cards in a very good way. They have given out a very user-friendly policy for solar.
Lovely. So, how do environmental factors, weather conditions, or geographical location influence the installation of steel in solar projects?
So depending on the geographical location, the structure for ground-mounted installations could be a sun tracking structure. The entire structure with the panels will rotate along with the sun's movement. And but that will be in the interiors where there's no humidity, where the mechanics doesn't hinder because of certain other problems. And serviceability is the most important issue in sun tracking installations. On seafront side, you definitely need hot dip galvanized structures, else your structure will corrode much before the system warranty also expires. And galvanizing is the basic only way. Painting is also another way of doing it, but the moment you forget once, it is gone. Once the corrosion starts, it will just eat up the structure round and round everywhere. And usage of hollow sections like square pipes, circular pipes is a big no, because to our naked eye we could see what is happening to C purlins or I beams. If there's any rusting happening, there could be rusting happening even though it is galvanized because of some flaw during galvanizing or anything of that sort, which can't be detected by naked eyes. But if such thing happens in a C channel or I beam, they can be easily seen and arrested. At that, a corrosion will stop immediately. But for a square pipe or for a circular pipe, for a pipe section, this corrosion can never be seen from outside because the corrosion will start from inside, and eventually one day the entire shade is gone down and nothing is at hand. So I would definitely recommend everybody in the industry not to use pipes at all. Let it be square pipes or circular pipes. Instead, use sections which are visible to your regular eye from all the sides. This will
Okay,
play a very, very important role.
that's a good piece of advice, sir. Is there any maintenance or inspection practice that you generally follow when we install steel supporting solar installations?
Yeah, definitely. As I told you rightly, wherever the concrete meets your vertical steel section, that is the first spot where corrosion would definitely attack. The second spot is where you nut bolt two C purlins to each other. So using a punching technique, the hole is punched into the C purlins. At that particular spot, the punched hole doesn't have galvanizing at that particular point where the hole is drilled, according to site conditions, probably at the site itself. So that is the second place where we have to look out, keep a watch for rusting. Of course, the nut bolts play a big part. They should be always stainless steel nut bolts, SS305. And we should make sure that all the bolts are tight and always in place. We have to use a regular washer, a spring washer, and if the installation is more sensitive, a check nut will also be a better added value to us. So these are the basic procedures that you normally have to follow.
And so, can you let us know in terms of with your previously done projects on solar projects, basically, if you could share insights or lessons that you've learned regarding the installation of steel in these projects.
For ground mounted, everything is okay because everything is pre-designed and prefabricated and just bought because you have a huge amount of space available. But for rooftop, prefabrication doesn't work at all because measuring the site precisely to inch or centimeter to centimeter or millimeter to millimeter is always not possible. And the tremendous work deadlines always keep on acting on us. So at that moment, what happens? We just take the material and according to site conditions, build it over there. At that particular moment, we have to watch the structural stability. At some particular moment, the Stratford report is not followed. The distance between the verticals is not followed properly. That are the design flaws which are prone to hazards in later on time in the year, because monsoon will always be coming and summer will always be coming, which will have high wind pressures, and they will act on their own and destroy whatever is not done properly. So these are the basic precautions that you need to definitely take.
Because you were talking about how the installation needs to be done, so can you also elaborate on what are the kind of skill sets, if there are any, that are required for people who do these kind of installations?
There are a lot of courses that have come up from n number of locations in Maharashtra specifically, where they teach about solar installations across Maharashtra to probably 12th pass students or something above that. And these students have already undergone a training for installation and maintenance of solar. So getting manpower from those segments would be a better option, and you automatically get a bit trained manpower. At least ones who have already been through the cycle of getting things installed. Else, virgin and fresh manpower is always there. We need to dedicate a bit of time to get them accustomed to our skill set and then judge them and then leave the site entirely on these people. Else, the vendor will be at a problem.
Got it. So we would want to also understand from you in terms of what are the emerging trends or advancements that have happened in the steel technology that could impact solar installations.
The steel technology, definitely everybody wants to have a steel which is cheaper in cost, so that their project economical viability also reaches the actual level. Everybody is there to earn. Nobody will do it for free. So situation being, steel, normally roll formed steels are used, and nobody basically goes on and check whether this is a virgin steel or this is a roll formed steel. But if the project is to be done properly, virgin steel is the most better one, better than roll formed, of course. The strength carrying capacity are entirely different for this sort of steels.
So I was actually going through your website and I saw a couple of products listed there, which is quite interesting, and I would want to understand, and of course I would like our audience also to understand what is on-grid and what is off-grid solar system.
Okay. Basically, on-grid solar system is a system in which you do not have any storage space at all. Storage would mean battery units. So whatever is generated is either simultaneously consumed, or whatever excess remains is given back to the grid via a net meter, which will go on reading how much has been given back, and the government compensates us return for that many units, again during the non-sunny hours. So this system is basically called as an on-grid system, and this system are cheaper in rate because there is no storage. the efficiency is much better because energy changes from one form to another form hardly 2 times over there. So the degradation of energy transformation is not there. But in a off-grid, in contrast, off-grid systems basically have a huge battery bank with them. This battery bank requires a lot of servicing. This battery bank is very costly. The product cost of on-grid and off-grid is twice. So off-grid is much more costlier. Off-grid is required only where the locations are very remote, where electric fluctuations always happen and there's no light at all. At that situation, off-grid system is okay, and that is the place where off-grid will be used. There's also something called as a hybrid inverter. In a hybrid inverter, what happens? It has a combination, it has a small battery and it has a combination of on-grid and off-grid both together. So major component is on-grid. That component, whatever is consumed is good, else it is pushed down to the electric grid, and the balance component is stored into battery for reusages during light cutouts. Because the on-grid system will work only when electric supply is on. If the electric supply shuts down, this on-grid system will automatically shut down. That's the basic difference between both.
Okay, so we've captured more or less about the functionality of it. Now, also, if we want to understand from you, if there are any schemes or special subsidies that companies get who are doing solar installations. So, in terms of financing, how smooth is it?
This is a capex-oriented product or industry. A lot of banks have come ahead. Most of the nationalized bank and quite a lot of scheduled and cooperative bank too give loan for such projects. And these loans could be for housing societies, for schools, colleges, educational institutions, hospitals. So these banks, they give such type of financing options. And our State Bank of India, Reserve Bank, these banks also basically give loans, and they have a special solar cell where such finances are already done. Anybody can walk into any nearest branch and get all the details.
Understood. Now, sir, we have a question from our audience. One question that we could definitely address is how did GoGreen Ventures venture into the solar space, and why the name GoGreen?
Okay. So my earlier business was basically related to telecom sector, and I could foresee a fall in that sector altogether. So simultaneously, I started with windmills, small windmills on rooftop of bungalows or buildings, because it had a mechanical touch, it had an electrical touch, everything was there in a windmill. And by God's grace, windmill took me a long way. Probably 10, 12 years down the lane, 8 years earlier, net metering started. Net metering is a process in which you need not have a storage. Storage is the grid. So whatever you generate goes directly to the grid or you consume, as I explained earlier. So at that moment, the business cycle changed entirely, and everything was like on a very huge scale. Everything multiplied itself by 100x. Not only for me, for all the vendors across the nation. Whichever states opted for this net metering policy, everything went that way. So I had already green concepts at heart. Mechanics was also dear to me, and I started with windmills in hybrid combination with solar panels, and eventually now I do wind and solar hybrid for buildings, bungalows or bigger farms in an on-grid or off-grid format. And that is the way basically I just got engulfed into this renewable energy generation category.
Lovely. Sir, I think while I don't see any more questions from the audience, if you do have any, please feel free to write them in the question tab and we will get them addressed. Thank you so much, sir, for coming on our today's episode. It's a pleasure to have you, and to get your insights is actually very, very wonderful.
Definitely. Thank you very much.